circle. Okay. Next, what is average radiation density? Okay. Please note down, density is different, intensity is different. Okay. There are two varieties. Now we'll see average radiation density. Okay. Average radiation, okay, density. Please do not worry about this average, because whenever you have average, what is the meaning of that? Not only here, even in circuit analysis, what is the meaning of average, sir? See, meaning of the average is, if it is DC, no problem. Okay, DC, even if you take average, instead of using all these things, you can simply use, if you know the RMS value, you can remove this 1 by 2. Once if you are given with the RMS value directly, you can write ERMS into HRMS. Okay, you have to be a little bit careful here. Okay, so this is power density. Okay, this are we are discussing about power density. Power density means what? Watt per meter square. Watt per meter square. Now, once if you know the power density, say, see, if I am having 10 watt power, sir, if I am having 10 watt power, okay, now I make my imaginary circle like this. In another case, also I am having same 10 watt power, but my imaginary circle is large. Now, what will happen? Somebody tell me what will happen? What will be the power density here? The power density PD, say this is PD1, this is PD2, power density in PD2. Okay, what will be the power density? Definitely, power density of PD2 will be less than the power density of PD1. But what we need, but total power is constant. But what is constant? Total power is constant. So what I'm going to do, see, now I want to measure what is the total power radiated. Now this, I am radiating 10 watt power. Okay, if I am having antenna in such a way, this collects power from all the surface. Okay, because 10 watt power is radiating. If I have antenna such a way, my antenna, I have keeping my antenna and the surface of the imaginary circle, then it will collect the entire power. Then it will collect the entire power. So how much power I am collecting? That is the total power radiated, because whatever the power you are radiating, the power has to be collected by the imaginary antenna. But in reality, you will not have that type of antenna. But for discussion purpose, I am telling mathematically. Okay. So the total average power radiated is equal to total average power collected by the antenna. So the total power radiated. So total power radiated. Now we know what is total power radiated, 10 watt. The notation is W radiated. That is simply is equal to power density, PD or PR, anything you can put, power density into ds. Okay, this is yes. Now the question arises here. See, in both the cases, total power radiated is same. Okay, but here you are on the larger circle. Here you are on the smaller circle. Here you are on the larger circle. Now, when you are on the smaller circle, your power density will be high. When you are on the smaller circle, your power density will be high. Surface area will be low. Okay, because surface area of this is small. But when you are on the larger circle, okay, power density in ds, when you are on the larger circle, definitely power density will be less. But your area will be more. So what is finally the observation is that is constant, because you are radiating 10 watt power only. You stand here, you collect your total power, that will be 10 watt. Or if you want, you stand here, then you collect your total power, that will be 10 watt only. என்ன டிரான்ஸ்மிட் பண்றீங்களோ அதை தான் ஃபுல்லா கலெக்ட் பண்ணுறீங்க. ஸோ வாட் எவர் த எனர்ஜி தட் யூ ஆர் transmitted, that energy only you will be receiving. So that is the idea of this formula. So once the formula is very simple, sir, but the concept behind that formula you have to understand. Okay, so once if you have power density, okay, you are somewhere, once if we know the power density there, if you stand here, you are standing here, sir. If you are standing here, you know the power density here, then you make imaginary surface, you make the imaginary surface, then you apply the formula, then you can calculate the what is the power radiated, what is the power radiated. That is the idea of this formula. So integral P dot ds, okay, closed integral because closed surface. Okay, and again you know what is ds. Ds means r square. What is ds? Differential surface, r square sine theta d theta d pi, d theta d pi. Okay, this is the relationship between the total power radiated and the power density. Okay, power density. Okay, so the total power radiated is what is the unit of this one? The total power radiated, that is always watt. Okay, total power radiated unit is always watt. Okay, next, another important and little bit confusing notation. So that is average radiation intensity.